Okay, so question 36. Draw the structure of each of the following. There are total 6 sub-questions in this, but we're just going to do the first 2, get you going. These questions are actually a little bit more difficult than they seem at first glance, and it really is important for you to have a good grasp on how we prioritize groups that are attached to alkenes. Okay, so let's go through the first example. So whenever you're going through these, first thing you need to do is figure out what your parent is. So the parent is going to be a pentene, so we're going to have overall 5 carbons in this molecule, so as the parent. So we're going to have 1, 2, 3, 4, 5 carbons. And so this 2 right here is telling you where your alkene is. So that's what this ene is indicating, is that you're going to have an alkene, and that starting carbon is going to be on carbon 2. So this is carbon 1, carbon 2. That's where we're going to have our double bond. Okay, and so we also have a tribromo. So we're going to have 3 bromines attached to positions 1, 2, and 3. So this is position 1. Let's put a bromine here. Okay, and position 3, 1, 2, 3. Let's put a position or a bromine on position 3, and then 4, 5. We're going to put a bromine on position 5. Okay, so we've taken care of the 1, 3, 5 tribromo. So now the only thing we have to do now is make sure that this is in the Z isomer configuration, and if not, we'll switch it. Okay, so let's go ahead and put a hydrogen on the position 2 just to make sure we have a clear comparison. Okay, so the way we talked about how we assign priority in class is we're going to go atom to atom, and when you're trying to assign priority, a big mistake not to make is to attempt to assign priority according to size. You never assign priority according to size, which is a common mistake that a lot of people make. So again, if you want to have some help from your book, go to page 133, and that will help you out figuring out priority. But for now, let's go through the priority for 2 different sides. So we're going to go through the left-hand side first, and then we'll go through the right-hand side of this molecule. Okay, so let's go through the left. The left-hand side, we have 2 different groups coming off. The first is going to be a hydrogen, and so the second group is going to be a carbon. So notice here that I'm not referencing the carbon and the bromine simultaneously. We're just going to go atom to atom. So again, the first atom that comes off of this carbon right here is the hydrogen, and the first atom that comes off this carbon down below is the carbon. And remember, the way that we assign priority is by atomic number. So between the 2, carbon has the higher priority because it has the higher atomic number. So this is going to get priority here. So this is the higher priority, this carbon right here. Okay, so then let's do the right-hand side. So the right-hand side, we've got the first atom that we come to is a carbon. So this is our first atom that we come to going up. And the first atom that we have, or that we encounter coming down, is our bromine. So notice again that I'm not referencing the carbon along all of these other atoms that are attached. We're just going by the first atom that we encounter. So the first atom that we encounter here is the carbon, and the first atom that we encounter going down here is the bromine. And between the 2, bromine has the higher atomic number. So the bromine in this case is going to have the higher priority. Okay, so higher priority, or HP, is going to go on this side, and higher priority here is going to go on this side. So in this case, it just so happens that we got everything exactly where we wanted. We have our high priority facing the same side, or is the same side of the alkene, and so now we actually do have the Z criteria taken care of. Okay, so this guy works out just fine. Okay, so now let's do the next molecule. So this is sub-question C. Again, what we start off with is trying to figure out the parent. The parent is hexene, and we're going to put the alkene bit on carbon 2. So 1, 2, 3, 4, 5, 6, and we're going to put our alkene on carbon 2, just like before. So now we're going to put the isopropyl on the 3 position, so we need to figure out what the isopropyl looks like. Remember, the isopropyl has 3 carbons on it, so methyl ethyl propyl, and we have our iso configuration, and that's going to go on position 3. So 1, 2, 3. Let's go ahead and draw our propyl that's in the iso configuration. So that's going to be the isopropyl. So that guy's taken care of. And now 1,2-dibromo. So this is our 1 position again, so bromine here. And we're going to put a bromine here for the 2 position, so 1 and 2. Okay, so we've attached all of our groups that we need to attach. This is the overall configuration. Now we just have to make sure that the way that we began actually ends up as the E configuration, and if it doesn't, we'll just switch it. So again, let's subdivide the alkene into 2 different bits, a top bit and a bottom bit. So we'll break this bond and look on the left-hand side. So if we look on the left, the first atom that we come into contact with is our bromine. If we go up, first atom that we come into contact, if we go down, is the carbon. Of the 2, the carbon is the lower priority, bromine is the higher priority, so this is the higher priority right here. Okay, and so now we have a little bit more of a complicated situation right here. So just to make this a little bit easier, I'm going to subdivide this and give these carbons different names. So I'm going to call this carbon that I come to first carbon A, and I'm going to call this carbon that we come to second carbon B. And just to make this a little bit easier, I'm going to go ahead and draw out all of the hydrogens. So here we know that carbon A has 2 hydrogens, and here for B we know carbon B has 1 hydrogen. Okay, so the way that we're going to have to figure this guy out is we're going to be a little bit more explicit with this example than we were with these other 2. The reason we have to do that is because, unfortunately, when we leave this carbon right here, this green carbon, if we go up, we encounter a carbon, and if we go down, we encounter a carbon. So there's no clear winner here. So this is when we have to figure out how to break a tie. So if we talk about carbon A right here, this is carbon A. Carbon A has 3 different groups that are coming off of it. So we have a hydrogen, and a carbon. So let's go ahead and put those on here. We have, a hydrogen, and another carbon. Okay, and we're just going to take this as if it was just the carbon, and not worry about this other CH3 right here. Okay, and that's going to make it a lot easier on ourselves later on. So next thing we're going to do is the same thing for carbon B. We have carbon B right here. So this is carbon B. So carbon B. What we have on carbon B is a carbon, and a hydrogen. So again, notice that I'm totally ignoring the fact that this has a CH3 and a CH3. It's going to make it a lot easier if we just think about the immediate atom that's attached to B. So to B, we have 2 carbons, so we have a carbon here. We also have another carbon, and we also have a hydrogen. So again, this is our hydrogen, this is our carbon, and this is our carbon. Okay, so notice how I'm ranking these from top to bottom as high priority to low priority, and it should be intuitive that carbon has a higher atomic number than hydrogen, and so carbon is going to be a higher priority than hydrogen. So again, for carbon A and carbon B, we have tie. Okay, and so if we go down the line, we try to break that tie with the next atom over. Okay, so if we're going to try to break our tie, the highest priority that's attached to carbon A is this carbon right here. Okay, so we have a carbon. Unfortunately, this carbon right here is tied by this carbon, and this carbon right here is this carbon that's attached to B. So unfortunately, this doesn't work because to help break the tie, because again we have an atom that has the same atomic number. Okay, so now instead of going down the chain even further, we just look at the next group that's attached to carbon A and carbon B. Okay, so since this first carbon didn't help us out at all, we look at the next group down. So the next group down is going to be this hydrogen here, and then we compare it to the next highest on carbon B, and that's going to be this carbon right here. And between these two, it's obvious that carbon has a higher atomic number, so this guy's going to have a higher priority, and this is going to be a low priority. Okay, so now for carbon B, overall carbon B is going to be the side that has the highest priority. Okay, so now we have high priority over here and high priority up here. Okay, and low priority down this way and low priority this way. Okay, so do we have an E configuration. And so the answer is, if we have an E configuration, the highest priorities will be on opposite ends of the alkene. And indeed, we do have the highest priorities up top and down below. They're on opposite sides of the alkene, and so these are going to be in an E configuration versus a Z configuration. Okay. Again, not too terribly difficult. It just takes a little bit of getting used to, and you have to be really rigorous about each step. Okay. So that's question 36. Again, if this is giving you trouble, you have at least 4 more questions along these lines on question 36, and I definitely encourage you to go ahead and do all of those.